In this video, we are going to talk about rotations. So a rotation is something that turns around and around and around. Ooh, you are getting dizzy. You will give Mr. Siemens your best work along with some chocolate. Alright, enough of that. So can you think of some things that rotate, that turn? What part of the bicycle rotates? Well, the wheels definitely rotate. The wheels rotate, but the whole entire bike doesn't turn as you ride. That would be an accident waiting to happen. But what the wheels do is they rotate around a centerpiece. So they spin around that centerpiece, and the back wheel does the same. It spins, but this centerpiece doesn't keep turning, or else the bike would be flipping around and you'd probably be ending up on the pavement or something in a bit of pain. There's also another spot on the bicycle that turns or rotates, the pedals. The pedals rotate as you spin and the pedals go around and around, but the centerpiece that the pedals are on doesn't move. It stays in one place. So that's what we're talking about when we talk about rotations. A Ferris wheel also rotates. You go around on the Ferris wheel, and all the while the centerpiece does not move. So everything else spins around, but the centerpiece stays in one place. So when we think about rotations, we have to think about rotating around a vertex, and in this case, the vertex that's being rotated around is P. So here's the shape. That's the shape. And its image is over here. And you can imagine that a person has put a pencil down right on the dot, on the vertex. So as the shape rotates around, this pencil right on the vertex doesn't move. And it always keeps the point. So you'll notice, when I take, too far, you'll notice that this vertex, the point right there, is the same for the shape and the same for the image, because it hasn't moved. And that's really important in rotations. We don't want our shape and image to be far apart from each other. They need to be connected by a vertex right there. Okay? Let's look at some more examples. Here's an example where the letter F right here, this is the shape, and here's the image. And the letter F has rotated around a vertex. Can you see where the vertex is, where it rotated about? It's right there. Yeah. And we don't want that to move. So it's like somebody put their pencil tip right on the edge, right on that vertex, and then with their hand they moved the letter F. And you can see that it's rotating around like that. So that's really important when it comes to rotations. When we describe rotations, we have to say how much it turned. How much it turned. And we do that by talking about fractions. A quarter turn, a half a turn, or 3/4 of a turn. So this is what I mean by that. When the minute hand on a clock moves from 12 to 3, it's a quarter turn. So from here to here, if it turns that much, we say it moved 1/4 of a turn. If it moves from the 12 to the 6, so from here to here, we say it moved a half a turn. And if it moves from the 12 to the 9, we say it moved 3/4 of a turn. And this is how we describe rotations. Half or a quarter turn, half a turn, and 3/4 of a turn. So let's look at some examples. When we describe rotations, we also have to say the direction that it rotated. So looking at this clock, if we go from 12 to 3, that's called a quarter turn. And because we're following the same direction that a clock would move, we call that clockwise. It's a clockwise rotation. A quarter clockwise rotation. If we start at the 12 and move to the 6, that's a half turn because it went halfway around, and that's clockwise. So clockwise is a phrase that means the direction that a clock would move. If we go the other way, let's say that I start at the 12 and I go all the way around to the 6 here, that is also a half a turn. It's a half a turn because I went halfway around. But it's going the opposite way that a clock would move, so we call it counterclockwise. It's a counterclockwise, meaning it goes against the way that a clock would move. So we call it counterclockwise. Here's a really neat thing. With this clock, we could describe it two ways. Because it turns like this, let's look at this hand and this hand. That's a quarter turn, isn't it? It went a quarter of a way. So we could call it a quarter turn clockwise, because that's what it did. However, if we went the other way, we could say that it went 3/4 of a turn counterclockwise. So you have to be thinking, which way are we turning it? And that's why the rotation arrow is so important. If you see an arrow that is moving clockwise, like this, you have to call it clockwise. But if it's moving this way, that's counterclockwise. In this example, here's the vertex where the shape is moving to the image. And we can see that it's kind of like putting your pencil right on that vertex and then taking a piece of paper that's in the image of the shape or the same size and moving it with your finger while keeping your pencil firmly in place on the vertex and moving it over to here. And you'll see that right here is an arrow. Do you see that pink arrow? That's telling you that the image moved this way, not this way. So then we describe how much did it turn. Well, if you think of a clock again, and it moved from here to here, that's a quarter turn, and it moved clockwise. So remember to always start at the shape and then look to the image after. Let's look at another example. In this example, again, we start with our shape, which is here, and we see that it moves this way. So because of that arrow, that rotation arrow, and again it moves around a vertex, so they share a common vertex. And we could say that this shape moved a quarter turn, because if we think about like a clock, it moved a quarter turn counterclockwise. Counterclockwise, because it moved the opposite way that the hands on a clock would move. So remember, when you create a rotation, you will have your shape, and let's say your shape looks like this. And then you have to turn it about a certain vertex. So maybe the vertex is this one right there. There's the vertex. So what you want to do is cut out a piece of paper that's this size and shape, that's congruent to this, and then you're going to stick it on top of your shape that you have. You're going to put your pencil right on the vertex so that it doesn't move, and then you're going to turn the shape however much you need to. So let's say you had to turn this shape a quarter turn counterclockwise. Well, then it would end up looking like this. It ends up looking like that. So that's really important, to make sure that you put your pencil on the vertex and then take a shape and move it. Physically move it, because if you just try to guess where it'll end up, that's really tough, okay? So keep that in mind. And remember, clockwise means to turn it the way the hands on a clock would move, and counterclockwise means to move it the opposite way the hands on a clock would move. All right, good luck with rotations. Have fun, and there you have it.